So let's start. So this is chapter 1, lesson 2, simplifying expressions. We're just jumping right into the second lesson here. A lot of this will be a repeat of Algebra 1 and some clarification on things that you guys have been missing. So we'll start with numerical expressions or numeral. Now, if you're looking at your slide and you're like, I don't have some of that stuff, this is the point where you start copying that down because that's how you get it unless you want to spend double the amount of time to go back and do it later. So a numerical expression or numeral. A numeral is just a symbol that represents a number. These are the numbers that you write all the time. Whereas a numerical expression is a symbol or group of symbols used to represent a number. Like 3 times 4 represents a number. 5 plus 5 plus 2 represents a number. All of these things represent number, whether they have mathematical operations in them or not. What you don't see in here is you don't see any variables. There's no x's, there's no y's. This is just a numerical expression because it only has numbers in it and things that we're doing with numbers. So don't worry if I move ahead and you miss something. Don't worry. You can always go back afterwards. You can watch that video or you can grab the notes from somebody else. So the value of a numeric expression. So now we've got the numerical expression like 3 times 4 or 5 plus 5 plus 2 or 15 minus 3 is when we actually go through and figure out what it represents. Well, what does that represent? 3 times 4? Well, 3 times 4 is 12. 5 plus 5 plus 2, 5 plus 5 is 10. 2 more of that is 12. Everything up there, all of those examples represent 12. So when we talk about the value of a numerical expression, we're talking about kind of what is the answer to this. What does it represent? 3 times 4 represents 12. So now you might be like, why are we doing all this? Is because you might have a question that says, what is the value of this numerical expression? And you need to know what that means because I don't clarify those things. You're going to come to me on Friday and be like, when it says the value of a numerical expression, what does it mean? And I'll be like, it's just like we did on the notes. And then you're going to look at me all confused and I'll be like, remember when we did the notes? And you're going to be like, no. And I'll be like, I'm sorry then. So I don't want that to happen. We're just talking about the value means what is the answer to this? What number does that represent? Don't worry, if you missed something, we can come back a little bit. An equation. So the key thing to note here is an equation, this part right here. It kind of looks like the word equal, and that's what we're looking at. An equation has an equal sign in it. That's how you're going to represent it. When somebody says in all your math classes, when you hear an equation, it means it's something with an equal sign in it. It's a sentence formed by placing an equal sign between two expressions, called the side. So like when you're doing algebra and you add 3 to each side, it means the left side of the equal sign and the right side of the equal sign. We call those sides. The equation is a true statement if both sides have the same value. For example, a true statement might be something like this. 5 minus 4 is equal to 1 times 1. That is definitely an equation. 5 times 4 is something I can solve. That 5 minus 4 is 1, and 1 times 1 equals 1 as well. That is a true equation because when we're done with that, what we're going to end up with is that 1 is equal to 1, which is a true statement. Sometimes we will end up with equations that are not true. We dealt with that in Algebra 1 as well. You may not remember it, and we'll talk about later about what that means if something is not true, but you might end up with something that is not true, like 4 is equal to 7. That is not a true statement, not at all. And it means something in math too when we get there, like it ends up with like, wait, what? What does that mean? It means something. That's usually when we get to our no solutions because that doesn't make any sense. So where true ones are the ones where we're going to get to things like 1 equals 1, 2 equals 2, 57 equals 57. All right, so here are some examples of equations. The thing that I look for immediately if I were to say, hey, are these equations? The first thing I would look for is this. Do I see an equal sign? Because that's the dead giveaway. An equal sign. So I've got 2 expressions. Notice on the left, for the first one, we've got a numerical expression on the left and a numerical expression on the right that are separated by an equal sign. So now we have it. We call that an equation. So then we've got one that is not a numerical expression. It's got it's got a variable in there. 4x plus 3 is equal to 19. 3 times 4 is equal to 12. 36 divided by 4 is equal to 1 times 9. All of those are just equations. That's what we're talking about when we say, sometimes we say expressions, that does not have an equal sign. An equation, that will have the equal sign because, again, when you see this part, just think of it's like equal. 2 things that are equal. I'm going to keep going. If I miss something, don't worry. If you were like, hey, I didn't get that, I will come back afterwards to slides that you want. You can just say, hey, could you go back to this slide for me? And I will. No problem. I just want to make sure we get through most of the content. All right, so now we get to our inequality symbols, and I have to go back to like when I first started teaching. So when I first started teaching, I was not a high school teacher. I taught elementary school. I taught 5th grade, and then I moved on to 1st grade, and so it was really interesting for me because I would march these little kids like ducks down the hallway, like when they had to go to lunch or something like that. But when you walk a bunch of 1st graders to school, you think, hey, bro, just turn left up there. Make sure turn left at that hallway. And you cannot tell a bunch of 1st graders to turn left because the whole crowd goes like 10 different directions. They have no idea what you're talking about. The concept of left is not there for all of them yet. So what most people do, and a lot of you probably did the same thing, is when you were learning your left from your right, you might have learned this trick. That way if you just hold up both hands like this, one of them makes an L. The one that makes an L is your left hand, which is kind of nice. So if you're ever stuck, you're like, wait, which one's my left? And you'll see even still today, somebody will be like, okay, wait, this one's my left. I got that. Well, the great thing about math is that if you're one of those people that gets confused between the less than sign and the greater than sign, it still works. Take your hands, make the L, the one that looks like an L, is also the less than sign. So L, less than. If you're confused, because a lot of people just learned it as like the alligator eats the greater number. So if you're doing it that way, that's great. That's still true. Alligator does eat the greater number, but what that doesn't tell me is whether that statement says something is greater than the other number or something is less than the other number. We need to be able to say that the right way. Because if I give you a sentence in words and I ask you to translate it to like a numeric sentence or an equality or an inequality, you need to know those things right there. So the less than, if you can take your hand that looks like an L and you can make it so it rotate it so it makes that same shape, then that's the less than sign. So we got less than, greater than. Now that one that's an equal sign with a slash can either be said does not equal or is not equal to. It's showing you that two things are not equal. We've got the less than or equal to and the greater than or equal to. So those symbols are going to come in with our inequality, meaning two things are not equal. These things are not just equal. There's something weird about them. So it's kind of like an equality, but we use different symbols. So an inequality is just a sentence formed by placing an inequality symbol, all those symbols that we just saw, between two expressions called the sides of the inequality. So we've got two sides to an inequality. On one side we've got -3, and on the other side we've got -5. Now again, you can see that we've got a true statement here. If the proverbial alligator is eating the bigger number, -3 is a bigger number than -5. And if you're like, wait, what? That's because I would rather have -$3 than -5. That means I have even less money if I have -5. So the way that we say that now is just like we read it. Again, for those of you who aren't used to saying it like that, I've got -3. Now, is that the greater than or less than symbol? Greater than. -3 is greater than -5. When I go down to the next one, I've got -3 and -3/10, and I'm going to say it with this symbol right there. Which symbol is that? Okay, so I say it -3 is less than -3/10. So the whole point is that if I asked you to write it out using words or to translate into English what that says, you would know, because sometimes you really need to know, and that's like the SAT style questioning, that when you guys go to take the SATs, you're going to have questions that ask you about that. And if you don't know the difference between less than and greater than, it could mean the difference between a right or a wrong answer. It seems silly, but it could be a big difference in your score there. Yes, ma'am?
So you always read it from left to right? So
yeah.
Okay.
Yeah, I mean, you can translate in your mind, like when I see it, like I'm looking at the second one there, and I know by looking at it that -3/10 is the larger number, but if I were to read that to you, we would always say -3 is less than -3/10. All right, so we're going to use some of those symbols here. Now, this is the part where I really want, if you're tuning me out because my voice is so obnoxious, it is, I get it, but this is the part that I need you to focus back in, because a lot of people are going to come at me with like disasters for their homework, because they're going to be like, you really want all of that in the homework? And I'll say this. A lot of people are going to be upset with me after the first homework because they're not going to get full points for things, even though they got the right answers. And I'm going to show you exactly what I want. Is that this first, letter A, is a simple problem. We should be able to solve it, but you're going to be able to do a lot of it in your head. Even if you can do it in your head, I expect to be able to have you show me what's going on in your head. So if there's math involved, like 10 minus 2, I just want you to do it for me. 10 minus 2 is 8. 2 times 4 is 8. Now I can follow your idea of what just happened here and what symbol goes in there. Equal. Now, that wasn't a lot of work, but most of you could have done that in your head. I don't doubt that. Don't get me wrong. But you got to understand that these problems start off easy and they get to be much uglier things, and you need to be in the habit of like, I'm going to go step by step, because if I'm planning on not taking his midterm or final and I want to do well in this class, then this is what you're going to need to show in your homework. The homework is what usually gets most people. I'm going to do the same thing on the next one. Now the next one is a little bit more confusing. I'm going to do the same thing left to right. 27 divided by 3. That's 9. I'm going to write this here. Now this is two separate things going on. Even if you can do that in your head in what you consider one step, you're actually doing it in two steps. What am I going to do first on the right-hand side? Exponents. The exponents. And my exponent is right here. What does 3 squared mean? 9. Yeah, it's 3 times 3, which is 9. And I'm going to write it out like that. It shows me that you did that step first. Now you may be like, really? I got to do that? I could have done that in my head. But just, it doesn't take that long. Now I've got 9 and 11. Which symbol, what is the name of the symbol that goes in there? The less than symbol. 9 is less than 11. So this one on the bottom is just a line. It's not the equal then sign. So you might be like, really, I could have done all in my head? Yes, really, that's what I expect, because just the answers, anytime I see just the answers, the first thing I do is mark it wrong. I don't care if the answer's right. Doesn't matter to me. What I care is that when this gets ugly, that you have an idea of the steps that you need to take. All right, so now we get to a loud beeping sound. We get to sum, which is the result of adding numbers. When you add two numbers, you get the sum. But probably the part that everybody forgets about, here's our sum. We've got, those are the sums of those addition problems. When you have an addition problem, the answer is the sum. But the two things that we add together, we call the terms. So just so you know the different things, if I said, what do you call the two numbers that you add up to get the sum, you would tell me those are the terms. The two terms add together to get the sum. It's just the other name of them. And again, it sounds like the silly things, but these are the things that start popping up in math more often that you're like, wait, I needed to know all those names? You betcha. Okay, so then we got the difference. Difference is subtraction. If I'm talking about the difference between my age and your age, obviously I'm going to take my age and then subtract away your age, and that would give us the difference. So we've got two terms there. We're going to subtract them. The answer would then be the difference between them. You subtract two numbers, you get the difference. That's all there is to that one. You can probably guess what the next two slides are going to be about. So we did sum, we did difference. The other two operations that we're going to do are the product. The product is the result of multiplying numbers. And the numbers that we multiply, we don't call those terms anymore. What we're going to call them are the factors. Like 6 times 15 would be 80. Those numbers multiply together. Oh, sorry, I realize that it's delayed here. So I'm just waiting for the slides to catch up. And it's down. Okay, so pause for... Okay, so for the time being, it's up on the little TV while I get this started. But you can see that the two numbers that are being multiplied are the factors, and the answer in the multiplication problem is the product. Again, it's very easy, like when you get to these things, like when you get to Algebra 2, this is the highest level math that you're going to see on the SATs, which is kind of like your entryway into college, whatever college it is that you want to go to for whatever reason. So you want to do really well on that. And there can be questions as simple as like, what is the product of these two numbers? Well, then you would need to know what product means. If you know it, great, fantastic. If I said, give me two factors of this number, you would need to understand it's like two numbers that could be multiplied to make this number. So all of that comes up. All right, we'll stay up there until this comes up. So the quotient is the answer to a division problem. There's lots of ways to represent division. So we've got like 35 divided by 7 would be 5. That is the quotient. It's the answer to a division problem. 10 divided by 2, that's also 5. That's the answer. But a lot of times we forget that fractions are actually a way of representing division. If I give you that improper fraction, 72/9, really what I mean is do that division and tell me what it is. How many times does 9 go into 72? Well, it goes in 8 times. That's how we get it. So when this gets bigger, and we're not just talking about simple fractions, when it gets to be really ugly fractions that have x's and y's in it and everything's like canceling out, what's going on, you still got to understand that any fraction is just division. It's a form of division. Whether we can do it or whether we cannot do it is a different story. There's only so far we can get in some of the problems. So that's what we're looking at. I'm going to try to switch back to the big TV now. Okay, sorry about going back and forth there. All right, and then we get to our exponents. Again, all this is going to have to do with that grouping, and please excuse my dear Aunt Sally, that's where this is all going. So a power is a product of equal factors, meaning like I'm going to take 3 times 3, or 4 times 4, or 7 times 7 times 7. We're taking the same thing and multiplying it by itself over and over again. That repeated factor is called the base. And a positive exponent, meaning it's got to be a positive number, tells the number of times that base occurs as a factor. For example, if I have 4 to the third power, that means 4 times 4 times 4. Well, 4 times 4 is 16, and then 16 times 4 will give me 64, just the other way to represent that. Now, in that example here, we've got the base, which is that 4, and then we've got the exponent, which is that number up there. Just in case so you know which one is the exponent, which one is the base, it shows us exactly which one is which. So here are some examples of powers. So for example, let's say that we're using the base of 3. 3 to the first power is 3 and our exponent is 1, which is just, you've got 1 3 there. Oh, sorry. Whereas 3 to the second power is 3 squared, or 3 times 3, which gives us 9. 3 to the third power is 3 times 3 times 3, or 3 to the third power. With 3 times 3 is 9, times another 3 is 27, and so on and so on. So we can keep going more and more. Now, somebody impressed me here, and I can tell you, if you're not sure about this answer, do not go with your gut instinct, because this is the one that if you're like, I'm not sure, but I can take a guess, the guess is usually wrong. What would 3 to the 0 power be? 1. Now, this is a rule that we've got in math. We have to be very careful because most people's gut instincts would tell them that this is 0. You're like, but wait, I've got 0 3s. If you want some time, I will take you through the very long and nerdy explanation. I think it's cool. Most people who are not math people, though, you'd be like, you're a dork. Why are you doing this? And like, so it's the same as 4 to the 0 power is 1. 5 to the 0 power is 1. 1,876,542 to the first, to the 0 power is also 1. Any number raised to the 0 power, with the exception of 0 doesn't work, will always equal 1. That's one of those rules that comes up occasionally that we need to remember. So it's the 1 power that usually gives people a lot of trouble. So it doesn't come up that often, but when it does, you should know that that's what that means. All right, so your notes and my notes got cut off here. Something happened, so I'm going to add on to this. So grouping symbols, like when we talk about the P, and please excuse my dear Aunt Sally, the parentheses, it's not just those. It could also be brackets, and brackets kind of look like this. You've seen them on the keyboard, or maybe you've seen them in math. They look just kind of like that. It could be parentheses, brackets, or a bar. And when I'm talking about a bar, I mean like the one you see in fractions, because there is both a top and a bottom to that fraction that need to be done separately. If there's math to be done on top, do the math on top. If there's math to be done on bottom, do the math on bottom. Don't try to do it until all the top and all the bottom is as much done as can be. So it could be a bar, and they are used to enclose part of an expression that represents a single number. Again, I'm sorry this got cut off. I did not mean for that. I meant to give you this part. It could be a bar. It could even be, I'm embarrassed that I don't even know what the name of the symbol is, but those ones that look like this, those bars there, the grouping symbols. So the substitution principle is one that you actually know very well. It just says that an expression may be replaced by another expression that has the same value. You know this very well because if I gave you something like this, I'd be willing to bet that without a whole lot of math, you could tell me what number is supposed to go in there for x. What number is supposed to go in there? 5, because 5 minus 2 is 3. So we understand that x is equal to 5, so we can substitute that in there. That's what we're talking about. We can do 5 minus 2 is equal to 3. Since x is equal to 5, it's okay to replace every single x with a 5. If I know what x is, I'm allowed to replace every single time I see an x, I can put a 5. Also, if I saw a 5, I could put in an x. Whatever I wanted to do. Let's say one time, maybe it's better to have x's in there than it is to have 5's in there. I don't know. But the substitution principle says if something is exactly the same, then you can take out one and put in the other instead of it. All right, so the order of operations, I'm not going to expand on this. You learned this once, and it goes like this. But I'm going to tell you something that a lot of people learned the incorrect way. So we've got, please excuse my dear Aunt Sally. If you learned it this way, it tells you to do your parentheses, then your exponents, multiplication, division, addition, and subtraction. But one of the things that I find is that when most people do this, they believe, okay, I do my parentheses first. I go on to exponents, and then I look for multiplication, which would be totally wrong, because actually multiplication and division are equal. They're a nice little married couple here who both of them are exactly the same, like no one is not more important than the other. We always look for multiplication and division at the exact same time, and the way you decide which one to do is you go from left to right. Whichever one you see first on the left, that's the one you should do first. So don't always go for multiplication before division. You might not end up in the right answer because multiplication and division, one is not more of a priority than the other. Go left to right and solve them. Same goes for addition and subtraction. One is not more powerful than the other. Addition and subtraction, they're a nice little married couple left to right. So again, this shouldn't be anything new. We're just doing our order of operations, left to right, parentheses, exponents, multiplication, division, addition, and subtraction. So same things that you've always learned on those, but here's what we're going to do. So any of you have spent any time on any social media, you usually run across a problem like number 1, where it's like people are disagreeing left and right as to what the answer to a very simple math problem is, and your answer to that is if you follow your order of operations, you will always get it right. So I'm going to go through my list. Parentheses. Now looking at A, we're not looking at B yet. Looking at A, do I see any sort of grouping symbols? Parentheses, brackets, like a bar that divides a fraction? No, so that one's out. Do I see any exponents? Now multiplication, division, I see both. One is not more important than the other, but how do I decide which to do first? Start on the left. So I'm going right here, 2 times 5. This is the same amount of work that I would expect to see in your homework, 10. And now I'm going left to right, and I'm also going to do division over here. 6 divided by 3, that would give me 2. So right there, I've done 2 parts. I've done the multiplication, and I've done the division. Now I go, well, I've got no more multiplication, no more division to do. Now I'm going to do addition and subtraction. I don't see any addition going left to right, but I do see subtraction. 10 minus 2 is 8. Not a lot of work there, but I do expect to follow along. I realize most of you can do this in your head. When we get to B, it starts to get a little more complicated here. So now I've got 2 sets of grouping symbols, so how do I know which one do I do first?
The one with the brackets.
The outer one?
Yeah, that's one.
So I'm going to basically go along, and I see brackets, but inside that bracket, I actually see another bracket, which means it's even more important than the first one. So I'm always looking for the innermost one. Like, so this one right here is the first set of brackets, and I go, okay, I'm going to work in this bracket. So partially you're right there. But inside that bracket, what do I do first? The next set of brackets, which is even closer. So really where I'm starting is within that red area right there. Now, I still need to obey the same rules. So I'm just going to write out the first part so I don't lose it. I'm just going to go, okay, so I've got 2 times 4 plus. Now I know I'm working in the red brackets here, so I'm just going to leave that open for myself for a second. Now, when it comes to 2 cubed minus 1, what am I going to do first there? The exponents. 2 times 2 times 2 is 8. So 2 times 2 is 4 times another 2 is 8 minus 1. Now I'm still working in that red parentheses. So remember, because I got to follow my grouping. So even though there's multiplication going out there, I still got to follow my grouping, and my inner grouping says to do 8 minus 1. So here's what I'm going to do. 4 plus, what is 8 minus 1? Okay, I'm just going to leave it in parentheses there. It's okay if you didn't. I'm just trying to show there that that's where that came from to help you follow along. What is my next step I'm going to do? The brackets. I'm still in my grouping symbols. I got to work within there. So right there, I've got 4 plus 7. And what is 4 plus 7? Okay, so it's 11. So I'm just going to leave the brackets there for a minute so we can just see where it came from. It's not that we need them there, but it does separate the 2 from the 11. What do I do with that 2 and 11? Multiply them, and 2 times 11 is? Bam. So that's the kind of work that I said, if this was your problem, that's what I would do for the homework.
Couldn't you also use the 2 and multiply it by the 4 and then multiply it by the 7? And
So what you're doing is called the distributive property. So you could do that, but really when you're talking about order of operations, the reason that we should know the order of them, you can do the distributive property and then do them in both. But a lot of times when people get stuck, where do I go? When you are in a pinch of what do I do, you can always go to your order of operations. The idea is because it won't just be as simple as numbers now. Now, C is certainly confusing because it's not as obvious as you would think. So, do I have any grouping symbols? Yes, and that's the one that throws people off. Where is my grouping symbol? The bar, yeah, right there. It's not what we normally think of there. So really it tells me that there's something that needs to be done there, either top or bottom, maybe both. So there's my 5 squared. So what can be done, top or bottom? Top. So we're going to go there and we're going to go 5 plus 1 is 6. Now, when we talk about those grouping symbols, there's nothing left to be done on the top and nothing left to be done on the bottom separately. Would you agree with that? Now, it's still a division problem. I'll agree with that. But so I still need to obey my rules here that I go, well, I'm not to the division stage yet. I was at the grouping stage and I did everything on top and I did everything on bottom, so I'm okay for that. So next I'm going to go on to my exponents. I'm going to change colors because I'm going to write on the white part here. So 5 squared is 25 minus, now I can do that. Okay, now I can do my division. What is 6 divided by 2? 3. And 25 minus 3 is? 22. So it's easy to get wrapped up in what should I do first, and like a lot of times we come up with different answers because of our order of operations. All right, so a variable is just a letter that represents, it can represent a number or it can represent a group of numbers. It can represent more than one thing. And if you're like, wait, how could it represent more than one thing? You have factored before. And when you factored things, you found out that x could equal 3 or x could equal -2, depending on how you factored it. So there are situations where it can end up being more than one thing. So those things that fulfill x, that x could be the domain, we could call that the domain, or the replacement set. So when you hear those things, it's just the possibilities that x, a, y, whatever we're using can be. So for example, like it says, if the domain of x is 0, 1, 2, 3, means those are all possibilities that could be for x, we would write it like this. So here's a way of writing it that, oh, that's not the color I wanted. That x is a member, or it belongs to the set whose members are 0, 1, 2, 3. 0, 1, 2, 3 are all possibilities for x. That's what that is a way of writing. When there is like, if you want to show a set of numbers that it could be, that's what that means. There is a set, and the members of that set are 0, 1, 2, 3, and x is a member of that set. So I'm not so worried about the words you use here, but that you understand that it means that x can be any of those things. I don't know what the problem is, but for whatever that problem is, 0, 1, 2, and 3 could all be possible answers. So the value of a variable are the members of the domain of the variable, all the possible things, the number values that it could be. If the domain of A, so let's just say that there's the letter A, and we want to know what are the possibilities. It's the set of, let's say that it was the set of positive integers. Okay, so it's got to be a positive number. We know that. And integers are those like whole numbers. So we've got 1, 2, 3, 4, all the way up to infinity. That's what those dots represent. Keep going on and on and on. That represents a set that goes on forever, because no matter what number you give me, I can give you a number that's one bigger. So that's just the value of it, the actual numerical value. We're getting close to the end there. I'm trying to give you some time that you can go over some stuff. Now, an algebraic expression, when you think of the word algebra, you should think of variables, because until you started doing algebra, you never saw x or y unless it was like pre-algebra. So the word algebra, you should expect variables. It could be a numerical expression, a variable, a sum, difference, product, quotient that contains one or more variables. For example, 3 plus 4 is not an algebraic expression. However, 3x plus 4 is an algebraic expression. Notice the difference? All I changed was I added the x, the variable. That's what changed it. Algebra has to do with variables, missing numbers. That's what we're looking for there. So when you see that word algebra, that's really what it means, is there's some missing numbers. Could be 20 missing numbers, could be one missing number. That's what we're looking at. So there's a variable involved. So here are some examples of algebraic expressions. So I might have something like 2 to the 4th power plus 3x. I might have y squared minus 2y plus 6. All of these meet the definition. I might have something as complicated as a plus b divided by c, or 2c squared d minus 4d. I'm not expecting you to know what the answers to these are, but you should be able to say, well, I know it's an algebraic expression. I mean, it's a bunch of stuff with that are being added, subtracted, multiplied, and divided, and there's a variable in each of those scenarios. That's an algebraic expression. It is not an equality. There is no equal sign anywhere up there. So that's the difference between some of those. Equality, we're expecting equal sign. Algebraic expressions, we're expecting variables. All right, so we're going to do a couple problems here. So I know we're missing these. This got cut off. So we're going to add on, if x is equal to 4 and y is equal to 3, we're going to solve some of these. Now, just for time's sake, because we only have 10 minutes, I'm going to do these here. We've got, so our first one, we're going to do 3x divided by x squared minus 8. Now, the substitution principle says that since you told me what x is, I can go ahead and substitute it out every single time, and I'm going to do that right away. So every time I see an x, I'm going to swap it out with a 4. Why did I put parentheses around it? Because I wanted to separate that. I don't want to make it look like a 34. That's 3 times 4. And here, that x squared, I know that's going to be 4 squared. Sorry, my 4 is a little off there. Go back. 4 squared minus 8. So again, this is like a bar. So I'm going to do the top, and I get, on top, I got 3 times 4 is 12. On the bottom, what do I have to do first? Yep. I got in the parentheses, nothing to do, but then there at the parentheses is the exponent. 4 times 4 is 16, minus 8. So we get 12 over 8. That's an improper fraction that can be reduced. What is a number that goes into both 12 and 8? 4. 4 goes into 12 3 times. 4 goes into 8 twice. 3 halves, which is an improper fraction. So let's say that we wanted to write this as a mixed number. We'll just understand that this is division. That's all we have to do. 2 goes into 3 once, with 1 left over. Now, if you haven't done this in a while, it's 1. It goes in there 1 time. Here's my numerator in the fraction. Here's my denominator in the fraction, just in case you forgot. So that's 1 and 1/2. That's where those numbers came from right there. And that one went right there. And I say that because when the numerator and the denominator end up being like x minus 4, that's still where they go. If you do subtraction, you get x minus 4, that's still going to be the numerator. So when these get ugly, you're still going to use that same idea there.
So you not leave it as an improper fraction?
So sometimes you might be asked to leave it as an improper fraction. Sometimes you might be asked to leave it as a mixed number. I feel like you should be able to do whatever one you want. In general, in algebra, we do not leave things as improper fractions. In geometry, actually, it works great. I love improper fractions when it comes to geometry. But in algebra, it doesn't work as well most times. Okay, so let me do another one here. We've got b. So we've got x squared y minus xy squared. Notice the difference is that on the left, the x is being squared. On the right, the y is being squared. Now, I'm going to do my substitution that I'm getting from right here every single time. I was told those things, so here we've got 4 squared times 3 minus 4 times 3 squared. So I'm going to zoom in on that there. I pulled those numbers from up top. So on the left, I'm going to go left to right, and I've got an exponent. So that's 16 times 3 minus 4 times 9. All I did was the exponents there. 3 times 16, I believe, is 48, minus 4 times 9, which is 36. The difference of 48 and 36 is? If you have to do it the long way, just do it off to the side, no worries. 48 minus 36? 12. But we had to obey our order of operations there. All right, so going on, I want to get to the absolute value, which is our last part of this. So we're going to move on to here. Absolute value are those two bars that look just like this right here. You may have recognized them. And it means that whatever we put in there is going to come out as a positive number. So if I put in a negative number like -6, it'll come out as 6. But if I put in a positive number, it'll still come out as positive. It doesn't do the opposite. It just always puts out positive numbers. What this junk here, this math nerd speak down here means is that if A is greater than 0, meaning it's of a positive number, and you put in a positive number, then you'll get out that same positive number. If A is equal to 0, and you put in 0, you'll get back 0. Same thing. The absolute value of 0 is just 0. If you put in a number that is less than 0, aka a negative number, then you will get back the opposite of that number. Notice negative A really means the opposite of that. Whatever you put in, you're going to get out the opposite. If I put in -4, I'm going to get out 4. That's only for numbers that are less than 0, negative numbers. Put a negative number in, get the opposite out, a positive. So we're actually going to do some where we fill in the numbers using absolute values. So here we've got x is equal to 3 and y is equal to -2. I'm going to use the substitution principle at the very beginning here. 10 times the absolute value of, now remember, I'm getting the numbers right here, 3 plus the absolute value of -2. Those bars are a way of grouping things together. I have to do what's inside of them first. So 10 times, what's the absolute value of 3? 3. And what's the absolute value of -2? 2. So we've got 10 times 3, which is 30, plus 2 gives me 32. That's the work I would expect to see on that. Again, if you had to do math, I want to follow along. Do the same thing on the next one. 2 times the absolute value of 3 minus 3 times -2, and that's the absolute value of those, over the absolute value of x times y. So remember, top and bottom. So I'm going to do the top.
My thing isn't working.
Don't sweat. Go ahead. We'll figure it out later. So I'm going to work inside on top. I'll start at the top. We'll go 2. The absolute value of 3 is 3. Minus, now inside here I've got 3 times -2, which is -6. So in a minute I'm going to take the absolute value of -6 all over 3 times -2. I'm sorry, we're just down to the last couple minutes. I'm just trying to go quickly, and this is the last problem we're going to do. So I still have inside things to do, like right here. So I've got 2 times 3 minus the absolute value of 6 is just 6. All over. Now down here, I'm going to just go, okay, well, there's some stuff to do in there too. 3 times 2 is -6. And the absolute value of -6 is just 6. All right. On top, 2 times 3 is 6. Minus 6 all over 6. 6 minus 6 is? What is 0 over 6 the exact same thing as? 0. So again, I'm not worried that you're not going to know how to do the homework, but I am worried that people are not going to show me how they got their answers, and I'm going to be very critical of that, and then you're going to turn on me, and you're going to get upset with me, and you're going to be like, dude, he's a jerk about that. I'd rather you know I'm a jerk about that in the beginning, so that you can be like, I know what he wants from it, so if I want to do well, whatever. Like, it's going to take some work, it's annoying. I would just rather you do well in it, because if you made a little mistake along the way, I can figure out where it is, where I can't sit there in your head all day and figure out where you're at. So that's all we got. This will be uploaded shortly, and you could find out anything you missed there.